Hi everyone, I'm Peter, and I'd like to welcome you to our talk. Today I'm going to talk about the multi-touch display that Dave and Robert and I built. But first I'm going to give an overview of multi-touch. So the in multi-touch refers to the fact that it allows people to interact with computers using more than a single pointer. This contrasts with most existing Windows systems, which pretty much assume a single mouse or pointer of some sort generating a single stream of X and Y events. There's many different multiple physical mechanisms to get 2D inputs. So one way you can try to hook up, you can try to hook up two mice to your computer and hack the OS at a low level and get events from both of them. But that kind of approach runs into an interesting problem, which is that the user then has to consciously figure out which cursor on the screen corresponds to which pointer. So at any time that you have multiple physical controllers and multiple cursors, the user gets saddled with this task of trying to correlate them. So one way to solve this problem is to unify the on-screen pointer and the pointer device. And of course, I guess the most elegant way I've seen to do this unification is to allow the user to just point with their fingers. And so this is why most multi-pointer approaches that you see are touchscreens, but it's good to know that they don't necessarily have to be that way. So when you put a multi-pointer and touchscreen together, you get multi-touch. Historically, in the past, a popular way for doing multi-touch is to use capacitive sensors. And these generally require custom electronics manufacturing. They were limited to research labs or specialty commercial vendors. Some examples are Fingerworks, who made some multi-touch trackpads. They were acquired by Apple, and I think their technology is in the iPhone and the iPod Touch now. It's actually interesting to note that the iPhone everyone's familiar with the fact that it's multi-touch. One of the things about the iPhone that's interesting is that a lot of the sex appeal there is not so much that it's multi-touch, but just that they implement single touch really well and have really nice UI feel in single touch. Jasmine is another company that has been making multi-touch devices. They use capacitive sensors overlaid on top of an LCD panel, and they make Lemur, which is like a configurable musical mixer synthesizer device, and they've also announced the device called Dexter, which is sort of a larger scale version of Lemur. And also at Mitsubishi Research Labs, they created a large collaborative table that was capacitive, and they were using that to explore collaborative computing. Another way to do multi-touch is to use cameras. And in the past, you had to get really pretty expensive machine vision kind of cameras to deliver the resolutions and frame rates that you needed to get really good responsive multi-touch. So again, a lot of work in this area was really limited to research labs and to specialty commercial vendors. TouchTable is one such company that's been doing this for a while. They make large-scale multi-touch tables. I think they're mostly targeted towards map visualization, GIS kind of applications. Another one that a lot of people have probably seen is the Microsoft Surface. The Surface, I believe, is in limited production right now, and they're meant for use really as entertainment kiosks or as, at the bar so you can order a drink or something. Now there's been, in the past few years, there's been a renaissance of experimentation with building homebrew multi-touch systems. And I think that's really because of the resurgence of cheap webcams and powerful processors. People are able to do machine vision at home with minimal hardware cost. Everyone, I think, has pretty much at this point seen a video of Jeff Hahn's light table that he presented at the TED Conference 2006. His table uses the principle of total internal reflection in order to illuminate the fingertips. He has some really interesting demos, and he's formed a company now called Perceptive Pixel. According to an interview I read, they're doing, I think, some defense contracting type stuff, and they do sell large wall-size displays. I remember, I think, last year's Game Marcus catalog had those things listed. I don't know how much they cost, but I think it's between a Bentley and Victoria's Secret Diamond Encrusted Bra. But that's sort of the range that they were going for. Now, a lot of you guys have probably also seen a very impressive demo from Johnny Lee at CMU. He's built this multi-touch whiteboard using a Wiimote and a projector and some infrared light emitting pens. His system really uses the fact that the Nintendo engineers have put a fairly impressive little bit of hardware inside the Wiimote that is able to track up to 4 infrared light sources and extract those from the image and then give you a stream of events out of the USB onto the USB bus. One of the disadvantages of this approach is that there's occlusion sometimes and you have to hold a stylus. But a major advantage is that you can just build this at home with very, very cheap hardware. You just set up a Wiimote. So this is a really neat way to implement multi-touch, multi-stylus. I think one of the most innovative homebrew systems that I've seen, that we've seen, is called the Reactable. And it's a university project out of Barcelona. It's used for doing collaborative music composition. And at last year's Austin City Limits, we actually got to see them on stage performing with Bjork. One of the things that Reactable does really well is that it interacts with physical objects placed on top of it. Because they've got this video camera underneath that's imaging the entire surface of the table, it's just a small amount of programming, right, to extract the markers out of these physical devices. And then you can have this very tactile sort of interface that's at the same time multi-touch and collaborative. It's a really neat way to put music together. If you guys haven't seen this, I highly recommend going to YouTube and looking for Reactable. So this brings us to our multi-touch table. We call it the PointIR, IR for infrared. We use a camera-based approach that's pretty much similar to the Surface or to the Reactable table. It's an approach that's called diffuse infrared illumination. And so the basic way that this works is that you have a projector that's rear projecting onto a translucent screen. You put some infrared lights underneath the screen that illuminate it and that don't interfere with the visual appearance of the projected image. And then you stick an infrared sensitive camera underneath there as well. And when the user touches the screen, the infrared light reflects off of their fingertips, and the video camera captures this image, processes it, and after quite a bit of processing, eventually gets you multiple XY events that your application can then go and do interesting things with. It's worth noting that just because, when we first say we're using infrared, everyone thinks, oh, you're detecting heat, so what if I have really cold hands or something? And this really doesn't, it has nothing to do with the temperature of your fingers. So, it's really not quite that simple. Those are the basic hardware elements that are involved. But there's some hardware difficulties that we had to overcome when we built this. The first issue that you're going to run into is the issue of insufficient illumination. We really need enough light to penetrate this diffusing surface that we're projecting onto to illuminate the fingertips. But we can't have so much that we get glare to the camera. And there's also kind of a health issue that you don't want to blind the user that much. People's retinas don't contract when there's infrared light. You're only responsive to visible light, but it still will burn your retina. So that's something that we got to be careful about. And don't worry, no one's going to get blinded using our devices. It's just something to be where you don't want to put 50 lamps back there just to brute force the problem. In general, though, you want more light because the more light you have, then the faster you can set the shutter speed on your camera and the less noise you get in each frame. So the machine vision problem of extracting the fingertips becomes much easier. A second issue that you get is that light levels across the screen are going to vary quite a bit depending where you position the lights and where your camera is. And even though we use this automatic thresholding to differentiate between the contact and non-contact areas, we still want the light to be roughly constant. This is a problem that we actually ran into when we were first using cheap webcams because they all have automatic exposure control, and you can't manually go in there and set the shutters at the gain and so on and so forth. And so what they'll do is when the image is fairly dark, they'll jack up the brightness and jack up the noise and all this stuff. And when you actually put fingertips down, everything then changes, and so your calibration and everything is thrown off. So that automatic exposure control is great for standard webcam kind of things, posting responses on YouTube, but it's not very good for machine vision. So even though we started off with a $100 webcam from Best Buy, we end up using still a low end, but still what we considered a machine vision grade FireWire camera. And the last issue that we have that you're going to run into if you try to build one of these is the issue of projector latency. most projectors have a 2 to 3 frame delay between when the image is actually sent to them and when it actually shows up on the screen. This is generally not that noticeable problem if you're watching a movie or if you're just showing PowerPoint slides like this. But for the multi-touch display, you've got your image, which represents what you're trying to interact with, and then you have your finger that represents the cursor. And if you have a 2 to 3 frame delay, you notice a significant lag. If you're just using a mouse on a projector, actually, you don't see this because the projector is telling you where the mouse is, and your brain automatically kind of compensates in your feedback for that little bit of lag. So, in some sense, this is a problem that we can't really solve, but in some other sense, it's also, depending how you look at it, it could be a completely solved problem because there are specialty vendors out there that sell very, very, very expensive high-end simulation-grade projectors that don't have sub-single frame lag. And so if you want to get one of those sticklers, then they get much more responsive, get a little bit of lag. When we first built the table, we actually played around with some of the existing software. And at the time, there were 2 image acquisition sort of processing loss detection libraries that people were playing around with that we found. And one of them was called TouchLib, and the other was called VVVV. I don't know why it's called, but neither of them quite did what we wanted to do. VVVV is a visual programming environment for video processing, and it didn't seem to be quite low level enough for what we were trying to do. We really wanted to have something that we could use as almost a driver level interface. TouchLib actually worked a little better. It was a better fit for what we were trying to do, but it didn't work very well with this rear illuminated diffuse illumination approach that we're doing at the time. And also, it was really tricky to get stable blob detection out of it. So we decided to write our own software. We wrote our own detection and processing software layer. By doing it ourselves, we have more control over the algorithms that we're going to use. We have a better understanding of what's going on, and we'd also be able to do it in PyCon using NumPy and SciPy. So those were all advantages of that approach, rolling our own. So the first step that you want to do the multi-touch detection is you need to actually acquire the raw video image. That's actually fairly straightforward. We use a FireWire library called DC1394. And it took a little bit of tinkering to figure out the right camera settings and getting all that stuff set up. But once you get that set up, it's pretty straightforward just to get the images off the FireWire bus. One problem that we have right now is that we don't actually have a version of the DC1394 that compiles on Windows. But our stuff all works on Linux and Mac. The next step that you want to do is you need to do basic image processing and filtering. Our filtering process consists of background removal and doing some foreground normalization. And this is all done right now, actually, in order to do this at the frame rates we wanted, we needed to actually do this, not just at C, but actually at the assembly level. So that part we can actually do in Python. Then the actual blob detection process is just really a thresholding rectification thing that you need to do. And what we basically do is you filter out everything that's kind of too dim to be an interesting fingertip. And by applying this entropy-based auto-thresholding approach, you can figure out the brightness points. We initially tried using OpenCV actually for doing some of this stuff, and using SciPy.NDimage, but to do some of the connected component things to find fingertips. But those, even though those are extension modules, again, they're not quite fast enough, and so we have to actually have to go to the hand-coded some algorithms for this stuff. And the last thing you have to do once you actually have fingertips out of every single frame is you need to figure out between frames which fingertips correspond to which other fingertips, so you can actually track them across the screen, across time. And this problem is actually, it's more generally called the correspondence problem. It's a fairly interesting problem. If you do the naive approach, you run into a wall at about somewhere around 8, maybe 10 blobs. You just can't quite do it fast enough because some naive approaches are actually super exponential. So we ended up coming up with a better approach that is able to handle 40, 50 blobs moving around and track them at about 55 to 60 frames a second. So the last thing you can do is you can do motion prediction and feed that back into the blob prediction, feed that back into the blob tracking actually. But we actually leave that off for the most part. So I'm going to show you some demos now of some of the stuff that we do. These are mostly all done in Python. The first app is one that we use just to test and to get metrics on frame rates and to see how long we're spending doing each of the processing steps. It's probably one of the most direct visualizations of the end result of the entire detection, tracking, and if we had to turn on prediction pipeline. This particular app itself is all written using Piglet. The next app then is fairly not a large intuitive jump to go from that to building a finger painting application. And this is a really big hit at Maker Faire when we showed this last October. The kids they're banging on the thing, getting ice cream on it. But this is sort of one of the obligatory apps that everyone writes when they have a multi-touch display. I think the reason why it's so ubiquitous, though, multi-touch, is because it's fun, it's easy to use. You can't quite see it because of the way that camera's set up, but as you're changing the colors on the color bar there, the streaks are also changing their colors. So, I don't quite see it, but that's starting to hint at some of the capabilities that you can get with multi-touch, that you can interact, configure a tool on a palette in one place and actually be using that tool or doing something with it in another part of the screen. And it's sort of, Robert likes to say, this is some of the power of multi-touch is not so much 25 fingers doing complicated gesture, but rather lots of single touch all happening at once. And this something like this you just can't do with single touch, so that's why I think everyone else likes to do it. One of the reasons why it's an obligatory sort of multi-touch app. So then another pretty ubiquitous multi-touch thing that people like to do is map visualization. And so we've written an interface to Google Earth that allows us to use our multi-touch device to interact with Google Earth. Now the pan and zoom operations, they're just very natural and pretty easy to use. Everyone knows how to do it. It feels really nice when you do it. It's interesting to note also that map viewing navigation we do just fine with the mouse. But the reason that, again, people show this off is just because it's so much fun and it's very natural. Now actually our Google Earth, and you might notice that it's a little jittery, and that's because the way we're actually doing this is we're trapping our multi-touch events, and we're using AppleScript to tell Google Earth to move the camera around. And then we know there's some sort of secret Google Earth API that we're not privy to, but if we had access to that, we can make it more responsive. So if there's any Googlers out there that might be able to get us access to that, please come up afterwards and talk about that. We'd really appreciate it. So then the next thing is actually using multi-touch for something a little more serious. Enthought is actually, at Enthought we do scientific software, and we're a scientific software company. And one of the things that we do a lot in scientific software is visualization. So Chaco and Mojave are two of our visualization toolkits or applications that we have in our set of open source libraries. This is showing Chaco, which is a 2D interactive plotting application. And it shows that we've integrated multi-touch actually at a fairly low level into the stack here. Chaco is built on top of a vector-based component model called enable. And what we've done is we've just stuck a new kind of event into enable. That's a finger touch event, basically. And it's pretty easy to take some of the tools in Chaco, some of the interactors, and make them just multi-touch aware. So we can make any Chaco widget, any Chaco primitive multi-touch capable. Another Chaco example that we've got here shows a plotting canvas, and it's a little bit hard to see the text, I think, because we've got this video camera going, the projector and all that. But you can see that you can select a data source on the left here on this toolbar, and it brings up a plot just showing you what that data source looks like. Now, if you touch two of them, it quickly shows you can quickly see the correlations between these data sets. And this is a very simple demonstration of something that is extremely easy to do with multi-touch, but that would be, with a single touch pointer, you have to click this one, or control click one, then control click another one, or click and click a tool and click another one. And so with multi-touch, you just don't have that at all. I mean, you just put your finger down and it's done. And you see, you can drag out new plots, you can interact with the plots that are dragged out. You can move the entire canvas around, scoot it off the screen, start over, bring some new plots up. So again, this is Chaco, and because we have this interactive plotting toolkit, we can plug in right into the middle of it and add some capability. Just a simple example of that. I think this is not the first multi-touch plotting I've seen, but this is almost certainly the first multi-touch plotting toolkit for Python. We also have a 3D visualization library called Mayavi. Actually, Mayavi is an application built on top of TBTK, which is a BTK. It's a BTK set of BTK wrappers, I guess, for Python. And we've made it interactive. We made it multi-touch capable as well. And what we're doing here is we're simply taking, again, taking the finger events, turning them into camera movements, and we're reaching into the BTK scene and changing where the camera is. Now this is the nice, pretty little mathematical function here, but you can imagine how for biology, for looking at a protein or looking at a molecule or something like that, this would be a fairly nice fun way of interacting with it. So these are some of the demos we have. We have some other ones as well. We've written like a sort of a multi-touch theremin type thing, but we didn't want to try to put that up here. So that's kind of, we've just written some demos now that we're finally at a point where our multi-touch stuff is pretty stable. And moving forward though, there's some other things we'd like to work on. One of those is we'd like to work on making calibration and configuration better and faster. Some of you guys may have seen us setting this up, in the booth, and there's several steps you have to go through, so we can improve on that. Another thing we want to work on is making better and faster fingertip detection. So right now, some of the problems we have are if there's a very bright background light that gets in the camera field of view, that can throw things off. And also, people have different sized fingers, and this is something that we'd like to take into account in the software as well. And one last thing is we'd like to add the ability to do sort of what the reactable table does, which is to detect markers and objects placed on top of the table surface. For a slanted table like this, it's not so useful, or for a slanted display, it's not that useful. But you can very easily, because it's just a projector, it's very easy to turn it into a horizontal table type of form factor. And for that, having actual physical markers that you interact with as UI elements is pretty neat. And the last thing that we'd like to do is also get a better lower latency projector, but we're just waiting for people to throw money at us for that. Now, like I said, our multi-touch input layer, as you can see here, is pretty responsive. It works really well. I see a lot of familiar faces out here that have come by and played with it. So now that we've solved this problem, we're actually ready to tackle the more interesting problem of what are you going to do with multi-touch? Right now they've got it. And so we'd like to build more apps, because that's what we do at Enthought, we write apps. And we do scientific computing, so data visualization is one of our core problems that we have to solve. So this is definitely an area that we're going to be working on and exploring. We'd also like to work on more games. Right now you can see we use Piglet for several of these things. Natural thing to do with Piglet, based on the traffic on the mailing list at least, is to write games with it, I guess. And so we'd like to explore that area a bit as well, and it's fun. And Multitouch is a very nice environment for games because you can explore different kinds of gameplay that you can't traditionally get. Usually multiplayer means multiplayer over the network, unless you have a lot of custom controls and everything, and break out a lot of controllers. But with multitouch table, you can really get much more interesting sorts of gameplay models. So we're looking forward to collaborating with people on that and working with folks on that. And one last thing that we can do is we can integrate with existing widget toolkits. And this is actually something we're a little bit torn about. We're not really sure if it should be that high of a priority for us. And the reason is because it's a very fun, doing a multi-touch widget integration, it's not clear to me that's really the best thing to do because most widget toolkits are made for single touch. I mean, they're made to, you can implement tree controls and drop-down boxes, you can put buttons all over the place. And the problem is that multi-touch changes how people want to interact with the device. And so if you stick them in front of a multi-touch capable panel of buttons, they're not going to be very happy. What they're really interested in is exploring it like a game interface. They want to look at their data, get their hands on it, move around in it. And so there's a reason why you see a lot of multi-touch demos are very much game interfaces. So the deal is that we really want to, building multi-touch, doing multi-touch is an interesting problem. I've said to, I guess many of you, when you come by the booth, it's easy to get to sort of the 80% point. You get 30 frames a second, you get your own fingers most of the time. If your kid comes up or a coworker comes up, they won't necessarily get their fingers. So getting to the 80% point is pretty straightforward. Getting the last 20% takes a lot of effort. To get the frame rates, we're getting 60 frames a second for 40 fingers. That's non-trivial for this sort of thing. And there's a lot of little gotchas, a lot of little hardware things we had to figure out. And so now that we've solved all these problems, we're really interested in applying it to solving bigger problems, more interesting problems at the application level, exploring large data sets, exploring very large amounts of statistical data that have a lot of different dimensions to it, looking at maps in interesting ways. So these are the sorts of problems that we'd like to work on moving forward. And if anyone out there wants to work with us on it, please come up, talk to me, or talk to Robert or Dave, and we'd love to hear from you. I'd like to also acknowledge some of the many toolkits that we've used. In doing this, we use NumPy, SciPy, obviously, quite a bit. We use traits all over the place. It's a type and event system for Python that also is an Enthought project. Choco, my obvious, we've shown here. We use Piglet for a lot of the GL drawing and getting access to the full screen and things like that. We use Twisted to implement our network protocol that actually dispatches the multi-touch events. And we use WX Python, bars, PyRX, everything. And lastly, I'd like to thank Travis and Eric for helping out with the slides and schematics and diagrams. I want to thank Enthought, the company, for giving us space and time and material support in this project. And I want to thank the people at Enthought, people who discussed stuff with us over tea, who've thrown around ideas and who bounce ideas off of. They're very helpful. So thank you very much.
Thank you, Peter, and thank you, Robert and Dave. All three of them worked on this together. We have about less than 5 minutes for questions, but if you have more questions, you're always, you can visit them in the booth down the hall. So, questions? Yes? What kind of patent or IP-related issues have you run into while doing this? Are there algorithms that you just can't use, or are there things that you can't do because of patents?
Typically, patent issues run into you, not the other way around. But actually, all of the work that we've done, that's a good point. Multi-touch has been going on. People have been exploring this since the 70s. And all the things that we're doing here, as far as we know, we got all the information off the web. We've looked at a lot of other projects that are doing similar things that haven't been suited to oblivion. And so we're pretty sure the stuff we're doing is pretty much in the clear. Machine vision type things like this have been going on, again, for more than 20 years. So.
Just real quick, Peter, how much does it cost in its current state?
You mean to buy one or to build one?
To build one for a customer.
Well, okay, so that's to buy one then, right?
Yes, we get to keep it.
Oh, okay. So the deal is the hardware itself, we got a projector, we got some IR lights, we have the camera, and then we have the cabinet itself. This one is put together at Home Depot, and if you'd like me and Robert and Dave to do your carpentry, then it's a little bit cheaper. If you want a more professional case, then that costs obviously more money. But really the key thing here is not so much the actual components, but the amount of time spent in figuring out the software level problems. Microsoft is selling these, I think they're planning on selling them for $10K plus, and you can only get it if you're like a Vegas casino and you're gonna put it downstairs with a big Microsoft logo on it. So we're probably looking at, less than that hopefully, but definitely it's gonna be several thousands of dollars.
Okay, we have time for about 2 more questions.
This seems to work really well with this distance and space of a hand moving in and out within a couple inches, I guess. How easy would it be to set it up to work to determine, detect the blood-like pressure with a hand or a piece of the body that was really close to the screen? Would that be difficult or easy?
Well, with our system, it's entirely visual, so it's really a machine vision image processing problem. So we can actually detect some level of sensitivity because we can see when the fingertips are smaller or larger. And so I guess you could sort of do that maybe for like an arm, definitely for finger scanning. You can put your whole hand on, you can put your whole face on, and you can do whatever. And you can simply set it up so that it doesn't throw those out, it doesn't just reject those. For our Google Earth and our Mojave and Choco demos, we throw out everything that doesn't look like a finger. So it's a software problem at that level.
So it could kind of completely detect pressure or force?
Yes, you could do something that's an analog of pressure. But again, I can't make any guarantees on how well that would work.
Okay, we kind of got to cut this down, but thank you very much, and please give Peter a round of applause.